I want to talk about the less common beta decay of particles and the ensuing anti-neutrinos that come out of it. The beta decay is simply when a neutron turns into a proton and ejects an electron and an anti-neutrino. At first, this may appear like it's in interaction with the electromagnetic force because of the ejection of an electron, but due to the fact that there is an anti-neutrino being ejected out of the neutron, it means that this is an entirely new force altogether. This is called the weak nuclear force. But I want to talk about this little guy because that symbol means anti-neutrino. And anti-neutrinos are basically chargeless particles that are the antiparticles of neutrinos. They're neutral in charge and they don't really interact with much. Whenever you see the existence of these guys, it usually indicates the existence of the weak nuclear force, not the electromagnetic spectrum. The weak nuclear force is millions of times weaker than the strong nuclear force, but it is the only process where a particle can turn into another type of particle, such as the neutrino turning into the proton. Now you might be wondering, where else do antineutrinos and neutrinos come from? Typically we get those inside of particle colliders by just smashing protons into each other, and out of the proton collisions we get the quarks and the neutrinos. Some of those quarks and some of those neutrinos will appear as anti-quarks and anti-neutrinos because they are the antiparticle of the particles that is essentially being created in the particle accelerator. Some of these anti-quarks can end up actually forming other particles, like anti-neutrons, which are just the antiparticle to the neutron. And just like in the beta decay that we covered, these high energy collisions can also create antineutrinos. The only difference is that these antineutrinos aren't born from like decay. If they're in the fireball aftermath of pure energy converting into mass inside of our particle accelerators. So whether it's an atomic nucleus falling apart in decay or an atomic explosion in a collider, antineutrinos are present basically everywhere, and they are the quiet messengers of the weak nuclear force. They're nearly invisible, but they tell us that beneath the surface, nature is changing identity itself, and I think that's fascinating.